Good morning, dear students. In today's lecture, we will talk about the last topic of this chapter, that is determination of molecular formula with the help of percentage composition of the elements. What you will be provided? You will be provided percentage composition of the elements present in the given compound. And by the help of this, you have to find out the empirical formula or the molecular formula of the compound. Now, the first thing, what do we mean by molecular formula of the compound? The formula which tells us about the actual number of atoms present in the molecule of that compound is called molecular formula. It tells us about the actual number of atoms present in the given molecule of the compound. Like for glucose, we can write the molecular formula as C6H12O6. This is the molecular formula of glucose. It means we can say here that a molecule of glucose contains 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen again. So this is your molecular formula of glucose. Now, what do we mean by empirical formula? The formula which tells us about the simplest whole number ratio of the elements present in the given compound is called empirical formula. Simplest whole number ratio of the atoms present in the molecule of that compound is called empirical formula of the compound. Means what is their combination ratio? So if we want to find out the simplest whole number ratio for this formula, then it will be 1:2:1, or we can write CH2O. One atom of carbon combines with 2 atoms of hydrogen combines with 1 atom of oxygen. This is the simplest whole number ratio of carbon with respect to hydrogen and oxygen in glucose molecule. The ratio is 1:2:1. So this is the simplest whole number ratio of the atoms present in glucose molecule. So CH2O is your empirical formula. So what you will do? By the help of information given, that is, you will be provided percentage composition of the element. By the help of percentage composition of the elements, you will first find out the empirical formula. And after finding out the empirical formula, we will find out factor N. Now what is factor N? Factor N can be written as N is equals to molar mass divided by empirical formula mass. Molar mass will be provided to you in the question. And empirical formula mass, first we will find out the empirical formula for the given compound by the help of percentage composition, and then we will find out the empirical formula mass. Like suppose you are getting for glucose, you will be provided percentage composition of carbon, hydrogen and oxygen. Then when you will solve for empirical formula, you will obtain formula as CH2O. Molar mass will be provided to you, that is 180 gram. Now what is the empirical formula mass? For carbon it is 12, for hydrogen it is 2 and for oxygen it is 16. So in total you will get 30 as the empirical formula mass. So 180 divided by 30 gives you 6. So factor n is 6. So when factor n is multiplied by the empirical formula, you will obtain the molecular formula of the compound. In this manner, we will find out the molecular formula. So here, one question is given, and it is, a substance on analysis gave the following percentage composition. We don't know about the substance, we don't know about the compound, we don't know about the molecule, but their percentage composition are provided. And what are the percent composition? Na equals to 43.4 and carbon equals to 11.3%. Add the percentage for the provided elements. If you are getting 100, then it's okay. If you are not getting 100, then the remaining percentage will be of oxygen atom. So here 43.4 plus 11.3 when added will not give you 100%. It means some other element is also there, and that element is your oxygen. So 100 minus this percentage will give you the percentage for the oxygen atom. Now calculate its molecular formula if molar mass of the compound is 106 gram. 106 gram is the molar mass of the compound given. So by the help of the percentage composition, first we will find out empirical formula, then we will find out factor n, and after finding factor n, we will solve for the molecular formula. So here in the table, 6 terms will be required: element, percentage, and atomic mass. These 3 terms will be given to you. Remaining one we have to find, that is relative number of moles, simple ratio, and the simplest ratio. This is the difference between simple ratio and simplest ratio. If the simple ratio is not a whole number, then we have to convert it into whole number, then we will get the simplest ratio. So what is the percentage for Na? Na percentage is 43.4. Percentage for carbon is 11.3 and percentage for O is 45.3. Atomic mass for Na, it will be provided 23. For carbon it is 12. For oxygen it is 16. Now next one is your relative number of moles. How to calculate relative number of moles? For the calculation of relative number of moles, we have to divide percentage with its atomic mass. Percentage with its atomic mass will give you relative number of moles. If percentage is more and atomic mass is less, then you will get more relative number of moles for the given element. So when 43.4 divided by 23 gives you 1.88, 43.4 is the percentage composition of sodium, and atomic mass of sodium is 23, gives you 1.88. Now for carbon it is 11.3 divided by 12 gives you 0.9, and for oxygen 45.3 divided by 16 gives you 2.83. Now in the next case, in simple ratio, what we have to do? You have to select the lowest number from the given 3. 1.88, 0.9, 2.83, lowest one is 0.9. So in the next one, what we have to do? We have to divide this number by the lowest number, that is 0.9. We have to divide 0.9 by 0.9, and then we have to divide 2.83 by 0.9. It will give you 2, 1 and 3. So it's a whole number. Simple ratio is 2, 1 and 3. So simplest ratio will be 2, 1 and 3. It means there will be 2 atoms of sodium, there will be 1 atom of carbon, there will be 3 atom of oxygen. So its empirical formula according to this will be Na2CO3. Now we have to check the molecular formula. Remember, empirical formula and molecular formula can be same or it can be different. So here we have got the empirical formula as Na2CO3. Now, empirical formula mass, when we add the atomic mass of Na, there is 2 atoms of Na, so 23.23 plus 12 plus 16 plus 16 plus 16 gives you 106 as the empirical formula mass. Now what is the molar mass provided? Molar mass is also 106. So factor N will be molar mass divided by empirical formula mass. It will be equals to 106 by 106 equals to 1. So molecular formula will be empirical formula into 1. So it remains as Na2CO3. So Na2CO3 is the molecular formula for the given compound when the percentage composition is this one. In this manner, we have to solve for others also. You will be provided percentage composition, make a table in this manner, get the empirical formula. Once get the empirical formula, find out the empirical formula mass, and after calculation of empirical formula mass, get the factor N, because molar mass will be provided. Factor N with empirical formula will give you molecular formula of that compound. That's all in this chapter. Thank you and have a good day.